Biomechanics is the study of human movement. We look at it from kind of a combination of engineering and physics. We look at how forces are applied to the human body or how the human body produces forces to generate movement, whether it's through clinical environments, looking at gait of an individual with cerebral palsy, or through an athletic endeavor of a person engaged in golf, baseball, walking, any kind of movement that a person does, we can generally capture in this lab. We're very fortunate in that we have amassed a large amount of very sophisticated equipment. Probably our main technology that we use is the motion analysis cameras. We have 28 cameras that we have 12 set up in our main room, which is our clinical gait type room or our general movement room, and then we have another 14 cameras set up in the other room, and we have 2 more cameras that we can use to whatever the movement is, might require 2 more cameras.
Marker placement is very huge. It's a very large part of what we do here. You have to know the body, like the bony landmarks, and you place markers on those to represent specific locations where you want models to be built from. The software uses inverse dynamics and gives us all kinds of outputs: joint angles, moments, powers, trajectories, velocities, accelerations, anything you can imagine.
We can be collecting data within 15 minutes, whereas other labs will take an hour or more just to get set up. We've worked with the animation group a number of times where they came in and they had an actor do some movements, and they can turn that movement into an animation as opposed to having to make those frames, and the movements look very realistic. We have multiple electromyography systems to measure muscle activity. So this is him trying to find the location of the middle of the muscle belly for whatever muscle we're looking at, and we're doing a rectus femoris right here. And then the electrode that they put on is a passive electrode. It just measures electrical activity of the muscle as she does any contractions. One of the machines that we have is a Cybex Isokinetic Dynamometer. The dynamometer is basically used to be able to assess muscle function across the various joints of the body. Here we can see an individual doing knee flexion and extension, and on the screen we can see their overall force production across the entire range of motion. The other thing that we also have designed here in our lab is the ability to be able to assess both the left and the right limb simultaneously, as an individual doing a squat type movement would do, whereas most Cybex machines are only able to assess the single joint at any given time. The golf team has been in here on a number of occasions to do motion analysis to try and fine-tune their golf swing. We can do a 3D motion analysis and look at the individual from any angle. We can rotate it 360 degrees. The gait analyses can be used from anything as simple as an individual who is experiencing trouble with joint pain when they're trying to run or walk. We can look at trying to model that individual, see how their joints are moving to see if they have too much or not enough range of motion at certain joints. We can try and modify that. We have an AMTI force instrumented split belt treadmill that allows us to be able to capture running and walking. The idea of the split belt treadmill is that it allows us to be able to have a person foot strike on one plate and toe off on the other plate. The Department of Defense was a major grant that was being conducted here, still is being conducted here, looking at the incidence of shin splints in new recruits as they enlist in the Army. Two phases that looked at different aspects. One was looking more at a fatigue. We fatigued the individual quite highly and looked at how their gait pattern changed while carrying a load of up to, I believe it was 75 pounds. And the second level was looking more at an activity history, where if you had an individual who was a runner and they ran in a unidirectional plane, they would load the bone and the joints in that one plane, whereas someone who played basketball is cutting every different direction to try and understand how the bone might adapt to that. Another piece of equipment that we have in the biomechanics lab is the Nero Comm Smart Balance Master. It's oftentimes considered the gold standard in assessing balance, and what this machine is capable of doing is trying to isolate both motor and sensory function as an individual tries to maintain balance. During any given trial, we can make the room move or the floor move in response to the individual's sway. So if the individual moves forward or sways forward 1 degree, we can have the room and or the floor sway forward that degree as well. What that in effect does is makes that information they get from their somatosensory system inaccurate, and we can oftentimes make the individual use their vestibular system, which is often not used as an individual gets older. This program is mainly a graduate level program in terms of the students that we have. We bring in master's students, anywhere from 3 to 5 master's students come in a year, and those students are involved in the research process from the day they get in the door.
I've already been accepted to a PhD program in New Zealand. The hands-on experience I've had with all the equipment is definitely going to assist me, because one of my key assignments in my new program is to be teaching their program one of the softwares that we have here. The experience here has been the most hands-on, absolute fundamental key to my success. So I don't think I could have gotten it anywhere else, honestly.